Hello everyone, welcome to another part of the P delta lecture. In the previous two lectures of the P delta, we have already seen the definition related thing regarding the P delta. We have seen what actually P delta is. We have already seen that what actually the small P delta, what is the big P delta. Also we have seen that in the previous part that when to apply the P delta in your building. This all thing we have already seen in the past two part of the P delta lecture. In this part of the P delta lecture, we will look at that how we can apply the P delta in our building, or we can say in our structure. So let us look at that. First of all, you have to unlock this model. Now for defining the P delta, you have to go into define option. Then you will get a P delta option here. You will click on this. Then one window will come here. You will get it three options. First is none. Second is a non-iterative based on mass. And third is iterative based on loads. So when you are not including the P delta, then you have to keep it none option here. So none will work when you don't want to include the P delta analysis. Now in ETAS, whenever you want to capture the P delta effect, it can be captured by the two method. One will be based on non-iterative based on mass, and second option will be iterative based on loads. Now you might be thinking that which is the best option to capture the effect, non-iterative or iterative method. So the right answer is iterative based on loads. Now let us understand first of all non-iterative based on mass. So first of all understand this thing, then we will understand that what actually iterative based on load is. So when you will want to capture the effect of the P delta by the non-iterative based on mass, in this particular option what will happen here, as I already told you that this method is a non-iterative based on mass. So when it is actually based on mass, then when it is required to calculate the mass of the structure, then it will be get calculated by story. The structure load will get computed automatically from the mass at each level. So like that it will be get calculated, and this is an approximate method, so that it does not require any iteration solution also. So that's the reason why actually it comes under the non-iterative. Now come to the next way of calculating the P delta effect. The next way is iterative based on loads. So in this method, when you select this method, then there will be required to apply the load pattern here. So I already told you that this method is based on iterative. So iterative means that it will have a repeating solution. Now you might be thinking that what load combination should be used for defining the P delta. For defining this load combination, you will take a reference of IS 16700 2017. So this is the tall building code. In the IS code of 16700-2016, one amendment has came in 2019 in November. So if you look at that amendment number 1 here, which has came in November, this is the code of IS 16700-2017 with amendment number 1, which has came in November 2019. So when you will come and when you will scroll down this code, and when you will come in the clause number 7.2, when you will come in the clause number 7.2d here, you will find a line here that the P delta effect, the P delta load combination for the initial analysis may be taken as 1.2 dead load plus 0.5 imposed load. You will also find that there is a lateral load also. So I already told you that in the definition of the P delta, you have to ignore the lateral load. So this lateral load will be get cancelled. So the load combination will be left with 1.2 dead load plus 0.5 a live load only. So this load combination you are going to use for the definition of the P delta in the required input data. So let us come and apply this load combination in our P delta option here. So this will be become that dead will become as a 1.2. You will add it. Live will become 0.5. You will add it. Floor finish will come under the dead, so this will come 1.2. You add it. Now wall load will come under the dead. You add it 1.2. Now live greater than 3 will come 0.5 here. You will add it. So like that you have to define the load combinations for defining the P delta option. Before the amendment came in 2019 in November in IS 16700, there was no any reference to define the P delta. So people actually, the different consultant were defining a differently load combination when it is required to define in the P delta. So some of the consultant are also defining the P delta option like 1.2 dead load plus 1.2 live load or 1.5 dead load. So one of the which actually the critical, we have to use it in the load combination for the definition of the P delta. I am not telling that this is the wrong way of defining the P delta load combination. This is also accurate. If you are following a Indian code and if you want to define the Indian standard load combination for the earthquake, it will be 1.2 dead load plus 1.2 live load plus minus EQ or wind. This will be the first load combination. If you look at the second load combination, it will be 1.5 dead load plus minus 1.5 EQ or wind, and the third will be 0.9 dead load plus minus 1.5 EQ and Y. So I already told you that when you want to introduce the P delta, in that case you no need to require a lateral load. So in this load combination of the first one, if you remove the lateral load, you will be left with 1.2 dead load plus 1.2 live load. So this is the same thing. Now in this one, if you remove 1.5 EQ and Y here, you will be left with 1.5 dead load only. So this is the same thing. Now in the third, if you look at here, this is not becoming any time critical, because if you look at here that this always comes 0.9 dead load. So always this will become a smaller only as compared to the first two one. So that's the reason we don't consider the third one, we only consider the first and second one here. So if you're following a Indian code, then you can define this load combination also in the P delta. After defining the load pattern, now let us come to the next term, that is a relative convergence tolerance. Now you might be hearing this word first time as a convergence tolerance. So what actually this word is? So the convergence tolerance is actually, we are going to check the displacement along each degree of freedom between a successive analysis iterations. As I already told you that this process which I have selected as iterative, it is always, there is a repeating solution we are getting here. So there will be some always repeating solution. So if there will be repeating solution, then we have to check also that if successive analysis or successive solution, what degree of freedom is getting in per column node. So if the displacement in that particular node of the column is going to be changed with certain limit here, so there is certain tolerance we have given that if it is, there is some tolerance limit, and if that tolerance limit is exceeding beyond that, in that case solution created will be called as converged. In general, the default tolerance which is used is good enough, so you don't need to change anything, you give it by default only what actually it is. After that you give it OK. If you want to introduce the P delta in the particular load cases as a geometrical nonlinearity, you can input this. So when you're defining the load cases, let us suppose that I am making a copy of these dead cases, and if I want to introduce here, then I will modify this and I will select this iterative based on load and I will give it OK here. So in this particular analysis, you will find here that P delta is applied here. Now if you're defining any other nonlinear load cases like a time history and all, or if you're defining a nonlinear static load cases, and if you want to introduce the P delta here, in there also you can introduce here. So in the geometrical nonlinearity option, you have to give it a P delta option here. So in the load cases, it will be get introduced here. So even if you want to define a auto construction sequence here, and in that case if you want to make it the P delta to be applied here, in that case you can just go to the geometrical nonlinearity option and you select the P delta option here. So when you select this as a P delta option, then geometrical nonlinearity will be applied here as a P delta. So I already told you that there is a three type of nonlinearity. One is your material nonlinearity, second is geometrical nonlinearity, and third is boundary nonlinearity. So this thing also we will see once again in our nonlinearity classes. After defining the P delta, you may run the analysis. Now we have come to end of the P delta lecture. So in the previous two part of the P delta lecture, we have already seen the definition related thing. So we have seen that what actually the P delta is, what actually the big P delta, what actually the small P delta. Also we have seen that when in your story is required to do the P delta analysis. So these are a lot of things we have seen in the previous two part of the P delta lecture. So in this part of the P delta lecture, we have seen that what the load combination you have required to define the P delta. We have also seen that amendment came in IS 16700 2007. Also we have seen a two way of doing the P delta analysis. So there is a two method of doing that. One was on based on load, which was an iterative method, and the second was non-iterative method, which was based on the mass. So we have studied a lot of things regarding the P delta analysis in entire lecture of the P delta classes.